Hi. So I hope you can hear me all right. So my name is Andreas, and why I'm standing here, or some information about me. First of all, before we start, if you have any questions during the presentation, just give a hand. We just take it from there. Okay, who I am, what I did before. I worked at a company called 4Players. Anyone heard about 4Players before? Some gamers here? Awesome. One of the biggest traffic sites in Germany a couple of years ago. And I was project manager and developer for something called the 4Players League. And this was quite funny because we did some esports, so online tournaments for gamers and stuff like that. It was really, really cool and really, really not that well visited at that time. And we started to play Dota 2, which was awesome. And we had some streamers who started streaming Dota 2. And we had 250,000 views. And we had the clever idea to say, awesome, come to our website, we have a raffle, just win something, and the server goes boom. So basically it was just gone. We had no opportunity to do anything. What we did was basically just serving static HTML files. But it was just not enough for 250,000 people at the same time on the servers. So this was my first contact with really big systems, or big-ish systems. And then I started working for the Online Fußballmanager GmbH. Yes, and they did a game called Online Fußballmanager. Really clever. So what we did there, I was a backend developer for the Online Fußballmanager and started tech direction for the new game Football Empire. And I asked my chef, well, okay, cool, so you want to have a multiplayer game. Awesome. Do we have a backend? And he told me, no. So, okay, I take care of it. How many players can we expect on the backend? Because it's a really, really important question for me, so I need how to architect the backend. And he told me, well, yeah, so 100K. And every backend developer says, okay, I can do that, not that complicated. And then he said, or 10 million. And at that point, we had an interesting problem for every backend developer. Because the thing is, even though we don't really reach the 10 million, we need an architecture where I can say, okay, I won't lose money if I just have 100K. So, an interesting problem. And I talked to every cloud provider out there and some bare metal providers. And I come to Microsoft and they told me, well, what you're trying to do is really basic. Was basically the idea. And they introduced me to service fabric in the actor model. This was, I think, 2.5 years ago. And we were the first actor-based multiplayer backend game ever created. Awesome. And we had operational cost of 2 cents per user per month, which was really, really good because we made enough money. Okay, so now I'm working at Microsoft. I'm a technical evangelist, and I'm in a team, Cloud and Games. What does it actually mean? I take care of game developers in Germany. I help them to solve their hardest problems, especially in backend architecture. Why is this interesting? Because especially in games, most of the time, there are really, really edge cases in terms of scaling and performance and high performance computing, and it's quite interesting. So that's the reason I'm standing here. So I'm quite familiar with Service Fabric, and I hope you will learn something today. Okay, so what will we talk about today? We have 5 main things we will talk about. The first thing will be what is actually the problem we have if we are building scalable backend backend architecture. Mostly for REST APIs and stuff like that. So where come microservices into play? What are actually microservices? How are they defined? And what problem do they solve? And what problems do they don't solve? Why do we need the actor model? And how does the actor model actually works? So how can I implement the actor model in my own application? And finally, we talk about Service Fabric, which is basically a platform for the actor model and some other stuff. Okay, so let's think about the problem. So how do we actually scale software, or in which dimension can we scale software? We can basically scale software in 3 dimensions. X horizontal, Y functional, and Z for data partitioning. Okay, let's have a look at the classical 3-tier model. Anyone here in the room actually built a 3-tier model before? Awesome! It's fun, isn't it? Okay, so let's have a look. We have some kind of stateless web front end, basically most of the time just speaking HTTP. We have some kind of worker middle tier who actually does the whole work. and we have some sort of database layer. Okay, cool. So we have different dimensions to scale. Let's start with the x dimension. Can we scale this in the x dimension? Yes, we can. Awesome. We just have not one server, we have 2 servers. Or 3 servers. Cool. So, can we scale in the y dimension? Yes, we can. We have a green service, we have a blue service. Awesome. One service for user, one service for leaderboards, or one service for the shopping cart or something like that. And we can scale in the Z. How do we do that? Called data partitioning. Basically, what does this mean? I don't have one database anymore, I have 2 databases, for example. And I have some kind of algorithm who decides which request goes to which database. For example, I have a user database, and the first 1,000 users are just located in database A, and everyone behind that is database B, data partitioning. There are some other ways to actually scale databases. Anyone worked with Cassandra before? Or MongoDB? Yeah. So eventually consistency is the magic word here. But what does this actually mean, or what problems does this introduce? The thing about that is, you're never sure if your data you are actually getting is the real data in that point of time. So you need to design your software to accompany that. Okay, so we know how to scale. We know that we want to scale the data layer in some way. We need data partitioning because everything else is bad. I mean, I can't just make the database of us so big, there's a limit basically for it. But we are all developers and we know how the real world looks like when we want to scale, and it looks like this. We scale horizontally, but still have one database. Awesome! So, the question at this point is, what will break? Database, right. So, bam, problem. Oh. So, but we are developers, and developers are problem solvers. So what solution have we to this problem? Right. So we just said, okay, cool. So if one database is just not enough, what can we do? Distributed cache. Awesome. Anyone in this room ever programmed cache invalidation? Yeah, it's fun. It's an awesome idea. Okay, so at this point we have reads against a cache, which is really, really cool because our database isn't that... Oh, so isn't that bad anymore, isn't that bottleneck anymore. But we don't know which data is actually current, or how do we invalidate the cache, and how to get new data out from the database, which is a problem. So, but even if we decouple it this way, if we read something, what's the next thing that will break? Anyone? Exactly. So writing something is the next big problem we have. So reading, it's okay, but now we need to write something. What we do? Write to database, but this will break. Okay, but we are developers, we are problem solvers. What have we introduced? Messaging queues, right? Awesome. So actually this is quite simply, because usually some worker would take the messages out of the queue and write them to the database, but just a simple version of that. So basically we introduce another layer, where we just put messages into a queue and pull them out to write into the database, because the database can't handle that much requests. Okay, so I don't know when I have a request when it's written to the database, I don't know when it's persisted to the database, and I don't know if the cache already has the new data or not. This is an awesome problem. So this is basically what we did, or what we do today, if we have the classic architecture basically. Okay, so, but Microservices makes everything better. Okay, so what actually is a microservice? Okay, a microservice is something that is separation by functionality. That's cool. And if we think about the definition of scaling, that's one factor to scale your software. So just split up your problem into different problems and scale it that way. Awesome. Microservices are small and easy to understand. So I asked some people and asked them, okay, how small is actually a microservice? How small should it be? And there are some people saying, well, it's just one class, it's just 100 lines of code. Others say it's 1,000 lines of code. So no one actually knows. But the idea behind the microservices is make it as small as you can understand it and as it needed to be. And the problem with that is it's a distributed system. So we are the microservice meetup, so I guess everyone knows about distributed systems. Yeah, they fail, yeah. Horrible, yeah. Okay, and at this point I think it's quite important to show this. Docker doesn't mean microservice. Docker is a great tool to actually build microservices, but it's not equal. Okay, so let's define microservices. And okay, disclaimer before we start. I started the presentation with this whole shiny animation stuff and that. And yeah, that took quite a while. So I switched to painting. Okay, so what do we have? Okay, we have some sort of service, and the service has logic and data. Awesome. And let's scale the thing. Does it scale? Let's try the x-axis. So horizontal scale. Oh, y scale. Okay. So we have just two services. Okay, we have service A, we have service B. Awesome. So if we want to have scalable software, we can have y scale with microservices per definition. Really cool. But the problem with that is that if I have microservice A and microservice B, I have something like that. So I have a dependency at some point. Yeah? So I have authentication, I have users, I have leaderboards, and the microservices want to talk to each other. What's the problem with that is that microservices and calls will fail because they are always networking calls, or not always, most of the time are networking calls, and they are supposed to fail, basically. So when you are writing microservices, you just need to keep this in your mind. So xscale, just have two services of the same kind. Awesome. And yeah, who sees the problem with that? If I just scale out my microservice, which has the data and the logic encapsulated in a microservice, and I just put out 20 of those. Exactly. So I have something like this. How I implement it is specific, but the idea is, okay, if I have 20 microservices but still one database, it's bad because I just can't scale the service so much because the database will fail at some point. So if I have some eventual consistency database, it's really, really cool, but some people need a SQL database for transactional stuff and things like that. So eventual consistency isn't the problem solver for everyone. And even if you use microservices, we have the same problem. And it's really interesting because every service who has a dependency to a service needs to talk to the service to get to the data. So the services don't know about each other's databases, which is good, but the database is still a single database. Even though I scale the stateless layer out, I still have state which I can't scale very well. So I just took this picture from lovely Martin Fowler, which is really, really great, to just give an idea about complexity with microservice and monolithic approaches. So what he is basically saying is that if you have a monolithic architecture, it's basically easier to implement and easier to manage. But as this architecture gets older and bigger, it gets very, very complex to manage and to extend. So the productivity of a monolith approach will fall down. So if you look at microservices, microservice productivity is at the start lower than a monolith. Why? Because I have the management overhead. Yeah? So I need to build microservices, I need to have a distributed system to actually have something like microservices, which makes me less productive. But if the complexity increases over time, the productivity doesn't fall that much as with a monolithic approach, because you enforce clear application boundaries. Yes, you can do this with a monolith too, but try to get your dev team to do this. It's not that easy. Okay, so what other complexity do we have if you talk about microservices? Transparency. So where is actually my service currently hosted on which VM? And how do I talk to it? And how do I find it? So naming services, service discovery and stuff like that are things to take care of. So reliability. What happens if a VM or a server just fails? What happens to the microservice? And what happens to the state the microservice probably will have? fault tolerance. Yeah, what we talked about earlier. I mean, you have to design your architecture in a way that they are supposed to fail. You have to anticipate it. And consistency for the data. Okay? So, let's compare these two. On the left side, we have a monolithic approach. So how does this work? I just have one application, I have 10 servers, and just scale this application out. Awesome. How do microservices work if I want to scale or orchestrate microservices? It looks like that. So I have a cluster of servers and have different microservices from different applications which need to be placed on different servers. And yeah, if you just compare these two images, microservices are per definition more complex than a classic monolith. Okay, so this is the stateless part. The stateless part is easy. The stateless part is always easy. So let's talk about state. Let's look at a state in a monolithic approach. So I have my stateless web front here, I have my stateless worker here, and I have my database. Awesome. So if I have a microservice approach, I have something like this. Yeah? So I don't actually know where my state is. My state could be, I can handle my own state, yes. But what happens to the state from my other services? Where do I store it? Are they reliable? Can they lose their state? And stuff like that. Okay, so round it up. What speaks for microservice is definitely it forces a cleaner architecture, which is cool because we all want clean architecture. You can do this in a monolithic too, but as I told you before, getting your dev team to a point where they actually follow the code guidelines is not that easy, at least in my experience. Okay, so what I can do is I can do independent deployments. So I can update service A, not service B, which is awesome because if service A fails, service B is still available, for example. So every time we talk about highly available systems, it's a good thing about thinking about microservices as well. Okay, so is it scalable? Per definition, yes, it is scalable, but not the state. Okay, what speaks against it? It's still a distributed system. A distributed system has problems that you need to solve, or you need someone to solve it for you. And resiliency and the increased management overhead is a really problem with microservices. Okay, so, but we are developers, and we are problem solvers. What have we done? Actors. Awesome. So the question is, are actors actually a solution to this problem? And the actor model is something that was invented 70 years ago, sometime back. And it was quite interesting because when it was invented, no one actually had the compute power to actually use it, which is awesome. So today we have really, really much compute power, so we can just use it. And what is an actor? An actor is basically an encapsulation of logic and data. So if you think back to our microservices, what a microservice actually is the encapsulation of logic and data, which is cool. So you can basically say an actor is basically a microservice. Awesome. That makes it easy to understand for us, because we have the same problems. Okay. An actor lives in the RAM. What does this mean? It's really, really fast, which is good, because load is no problem at this point. And an actor is usually really, really small, so you get many, many actors in one machine. Actors communicate asynchronously. So when they communicate between them, you have asynchronous calls between them. So if you think about it, fault tolerant and stuff like that, it's exactly that what we talked about before. And here comes the fun part. If you have a distributed system, or if you ever had the problem that you needed to program a multi-threaded thing, it's really, really hard to do because you need log objects and stuff like that, and you have some problems with your state, as always. So what the actor system actually introduces is single-threaded. An actor is always single-threaded, which means they call it term-based concurrency, which actually means you have less concurrency issues than you would have in a normal multi-threaded stateless application where you implement the multi-threading yourself to actually handle the load. Okay, so I'm an artist, so I painted a picture how an actor actually looks like. So we have some kind of message thrown to a network and reaching the actor. What will happen in the actor, per definition, is we have a queue in the actor, so messages get queued. Why? because the execution of the actor is single-threaded. We can't execute multiple messages at the same time in the same actor. Okay, so we have some logic which pulls the messages out of the queue and have some state which lives in the RAM to handle the state. Awesome. So these are actors. So what you basically get is free in-memory caching, which is really, really good. If you think about it in highly scalable systems where you just put a Redis or a distributed cache in it, you can basically get rid of the cache at this point if you implement it the right way. And how we do that comes next. Okay. So, okay, cool. We know what an actor is. We know that actor is basically a microservice, or we can define it as a microservice. But how can I actually implement an actor? So, there are different frameworks you can actually use to implement actor model. These are just a few of them. There are more out there that might suit your needs better. But we start here. So, first, Alex here, the idea is everything is an actor. Yeah, it's Erlang, it's functional programming language. Next. Okay, so we have Akka.NET. Akka.NET actually has a Java version as well. So Akka.NET is open source, so you can do whatever you want with it. You have full control over the actor system. What this means we will see in a minute. And the thing about control is that you are responsible for the things that are happening at your actor model level. And actually, this thing is usable in Service Fabric. How? I will show you later. Okay, what do I mean if I say you have the responsibility? Akka.NET is built some like that. So it's basically a graph where you have dependencies between your actors. So you have basically your main actor, and derived from that you have actor B and actor A. It's awesome. So, but why actually Akka does that is the question. And what do you do if an actor fails? Who takes care of it? Or the VM is failing where the actor is actually running on it. Who will fix that for you? And for Akka, the answer for that is another actor, or another node, basically. If you want to deploy Akka as a cloud service, or as a, how should I say it, as a cluster, you can do that. There's a module actually for Akka where you can just say, okay, I have a cluster, and just do it. Because Akka doesn't support it from themselves, so you need a module to actually use it in such an environment for a distributed system. Okay, next. Project Orleans. What is Project Orleans? Project Orleans is open source, was developed by Microsoft Research a couple of years ago, and they introduced something really, really interesting to the actor world, which is called the virtual actor. So we know that actors are basically microservices, and we know Microsoft has a problem, how do I find the service I need? And if I have state, it gets even more complicated. So if you think about an actor definition as a class, and the instance of an actor as an object, you can instantiate. To scale it out, you need an address to the object. So how do I get this? And okay, we know that the actor is living in the RAM, but how does the actor get into the RAM? So if I want to talk to an actor who is actually not existent yet, so I want to create a new one, I have to take care of where do I want to create it, what's the address of the actor, what happens if something fails and the actor needs to move, and what if I already had this actor and want to create a new one with the same name, for example. These kinds of problems are actually solved by the virtual actor model. Why? Because we are just saying we want to have an instance of this class and want to work with it. And Orleans does the rest. So Orleans says, okay, if this actor doesn't exist at all, I just create it for you and I put it in the RAM. And if you don't use the actor anymore, I just put it on the disk, on the hard drive. And you have more space in the RAM, which is awesome. And as soon as you try to talk to the actor again, I will take the state from the hard drive and put it back into the RAM again. Okay. Who actually uses this? There are some big games too. One of them is IO Interactive. They built the recent Hitman game. And the other one is Halo, so Industry 343, I think, was it? And they built their backend systems with this. And just to give you an idea why they used an actor model is that if you release a game, you have a high usage curve at the beginning, and it gets flat really, really fast. So they needed something that is actually able to scale that well. And the only way to do this was actually an actor-based model. So, and the Halo Studios is actually owned by Microsoft, so they used Project Orleans, who would have guessed. And IO Interactive said, okay, that's really, really cool, we want to do that too. And once again, Orleans can be used in Service Fabric. Why? We will see later. Okay, so now comes the big thing. Service Fabric. Internal code name a couple of years ago, Platform as a Service v2. Awesome. Okay, yeah, I put there a segment in there, Kubernetes on steroids. I know Kubernetes is really, really good. You should use Kubernetes for the right problems. But why I'm actually saying this is that Service Fabric is more than Kubernetes is. Service Fabric is not just an orchestrator to orchestrate stuff. It's an actor runtime too. So you can use the actor programming model to build your applications. What is Service Fabric? Service Fabric is actually used in internal Microsoft architecture for years. So we built this for hosting our Azure SQL, for example. So our managed database offering is actually running on top of Service Fabric, or something like Event Hubs or stuff like that, with billions of requests a day. And yeah, we just thought, really, really cool tech. We need to release it to the world to see what you can actually build with it. So, what does this mean if you think about cloud infrastructure and what actually Service Fabric is, if Service Fabric is a platform? So, let's look at a cloud platform or any platform. Yeah. So on the down level you have your servers. This could be physical servers, this could be VMs, this could be Azure, this could be AWS. I don't care at this moment. And I have some sort of application layer on top of it, and I can run application code on this application platform layer. And if you map this to some of our services we actually have, it will look something like this. So our old platform as a service offering, Cloud Services, is actually built on top of VMs internally. You don't see the VMs anymore, but they are actually running on VMs. So is Service Fabric. So Service Fabric is basically a platform to hosting your application code. Which this application code is, doesn't matter, because you can run anything on Service Fabric. And the higher up the stack I go, the more productivity I get. Why? Because less complexity. When I have just VMs running and have a database running on a VM, I need to manage the VM by myself, which is bad. If I use a cloud service like Azure SQL, I don't need to manage the VM anymore, which makes me more productive. And if I go the other way around, I get more control about the infrastructure I'm actually running, or the dependencies I have, or my code has for my infrastructure. And on top of that are some services. Okay, so Azure Service Fabric, what it actually is a platform for microservices. Yay, that's why we're here. The interesting part about Service Fabric is it can actually run anywhere, and I mean anywhere. So you can run it on Azure, you can run it on-prem, or you can run it on other cloud providers, but I don't know why you should, so. But you can do if you want. And Service Fabric is basically a platform which solves problems for distributed systems and for the actor model. Okay, so we just talked about infrastructure a bit, and we thought, okay, Service Fabric is cool. Does Service Fabric scale? Service Fabric doesn't scale. What does scale is the infrastructure and the application running on top of Service Fabric. So if you look at Azure, we have something called virtual machine scale set. What this actually is just a group of virtual machines, and you can scale them out automatically or manually, like whatever you want. And Service Fabric is just an executable running on top of these VMs, which is awesome. So if you think about scaling, scaling is done by the infrastructure provider, in this case Azure, or by yourself if you're running it in your own data center. Okay, a service fabric cluster. What can we actually do? We have an application, or we have two applications, which is quite interesting, because I have customers who are actually using Service Fabric who wrote a single tenant application. Multi-tenancy is really, really hard problem to solve on the application side. So what I did is basically they had the same application, but deployed twice into the same Service Fabric cluster, which made the application multi-tenancy, which is really, really cool and a really cool life hack if you're using Service Fabric. Okay, so I have two applications. I have some microservices or actors running in there. What can I do? Service Fabric will place them on your cluster. Okay, so cool. What happens if a VM or hardware fails? Service Fabric sees that and moves your services to another VM. It's awesome. As long as you don't have any state. And we know that actors actually do have state, because the state is living in the RAM or on the hard disk. So how does this actually get handled? The answer to this at the end of the presentation, when we have hands-on code. Okay, so what can I actually use on top of Service Fabric? Any code, so you can have any executable orchestrated by Service Fabric, or you can use the APIs or the programming model Service Fabric provides, like the reliable actor model and the reliable services. So, what are actually reliable services? Okay, we know already about reliable actors and what an actor is and how they work, but what are reliable services? So the Service Fabric team implemented something called reliable collections, which is really, really cool. So if you have, think about, you have a stateless web frontend, and in the stateless web frontend, you have a dictionary. If you scale it horizontally, so have just more instances of the same microservice, you would have 10 different dictionaries. Okay, it's data partitioning, some sort, but depending on which service I end up, when I request something, I get a different result. Which is not that good anymore, because I want the same result, because that's how applications should work. And the Service Fabric team invented the reliable collections, which is basically a distributed dictionary over a cluster of VMs on top of Service Fabric, which you can use as long as you're using Service Fabric as a programming model. And what actually happens is we have replicated state at this point. So Service Fabric takes care that the state for your reliable dictionary is not just on one VM, but on 10 or 20. So if a VM fails, the state is still up to date. So it's persistent, and it's replicated for high availability. What this actually means, we will see a few minutes later. But what this means is, if my server fails and I have a request against my service and the service is gone, how long does it take to actually get a request again, or response again from the same service? That's the question. And automatic failover is the answer from Service Fabric to that. So you just can kill any node where it's running some state, and Service Fabric does the failover for you. Why is this interesting? And why is this something we talk about when we talk about actors? Is actors work a similar way. It's a different programming model, but the idea is the same. I still have state replicas, and the state is persistent and highly available. Okay, so cool, but anyone tried to upgrade a Service Fabric, not a Service Fabric, a microservice system before? So with downtime and stuff like that? Yeah, it's fun? No, it's not. At least for me it was not fun. So the question is, does Service Fabric anything for you at this point? And the answer is yes. So just for example, we have a cluster of 6 nodes there. And we divided these nodes in different zones. One zone is called fault domain, indicated by the lines there. The other zone is called upgrade domain. And if I want to have an update running on my cluster, what Service Fabric does is it updates one upgrade domain at a time. This is cool. So I can have rolling updates with no downtime deployments. So I can just roll out a new version of my code and won't be down. I don't have a maintenance window where you just say, I will be offline for one hour if you are lucky, because we are just running an upgrade to our services. Service Fabric does this for you. And it does it a clever way. Everyone familiar with fail or update domains? Okay, so just a quick introduction. Why are we actually doing it this way? If you look at this, how the update domains and default domains are actually distributed. Even if I run an update right now, and fault domain I1 will fail, I will lose these 2 nodes. I still have these 4 nodes running the new version and the old version of my service. So even if I have a hardware failure during an upgrade, I still will be available, and I still have persistent state. So this is the idea of fault and upgrade domains. And if you think about fault domains in Azure, they're actually physically separated. So even if a rack loses power, there's still another rack with another fault domain where actually still has power. Okay. What else? We have code and we have config in Service Fabric. What does this mean? I can actually update code independent from my configuration. So if I have just some balancing data for my game, for example, and I don't want to change any code, I can just update the configuration and rolling it out, which makes an easier and faster update than code update. Because code updates are always scary. Always. Because they fail a lot, even if you have unit testing. Okay. So, now we can start with demo time. Any questions so far? Okay. So I hope the demo gods are nice to me today. I really hope so. Oh, they already closed my Visual Studio. Awesome. Okay, so what is actually Service Fabric? Service Fabric is an executable. You can just install the Service Fabric on your laptop or on your PC and can just start using it. And you can just manage your cluster locally. Awesome. What we're actually doing is we don't simulate Service Fabric for you, we are actually running Service Fabric on your machine. How do we do that? So let's open the Task Manager. So just to get an idea what Service Fabric actually is. You already see that I have some background processes running here. And what Service Fabric basically is a service running on your laptop, in this case. Funny about that is we have a Linux version of Service Fabric too, so you can run it on Linux too if you like. Awesome. So I get the same environment I have running for my services on my cloud platform or my production environment or my local environment, which is really, really cool because I don't have this, oh, it works on my machine, but not on mine. But because it's the same thing. Okay, so I opened Visual Studio and I have a project prepared for you. We start really, really simple with a stateful service test. So we talked about the reliable collection thing earlier, and this is basically to show you how it will work and how Service Fabric will handle failure and stuff like that, and it's easy to show it this way. Okay, so this is my Service Fabric application. I have some configuration over here. So you can see you can have different environments. You can have a production environment, you can have a staging environment, and just deploy different configurations to different environments, and you can automate all the things because Service Fabric has a management API which you can talk to. So let's have a look at the service. It's really easy. Yeah, I just have one async service, which is basically the entry point of the service once it gets started. And what I do here is I get my dictionary, which is basically a reliable dictionary. Yeah? This highly persistent dictionary and distributed dictionary we talked about earlier. And I say, okay, it's a string long and the value is my dictionary, so basically the variable name, if you like. And I can just use this dictionary as if it's a local dictionary. Yeah? So I can just say, okay, I have some sort of counter, starts with a 0, and I have a function passed into it how to calculate a new value. In this time, I'm just incrementing the value. But I'm just not incrementing the value, I'm incrementing it by the partition ID. So if you think about data scaling, what we talked about earlier, this is exactly how we scale data, with partitioning. And so are services scaled in reliable services. Now I can just hit F5 in my Visual Studio. I will compile the whole service, package it together, run a deployment script, which actually just goes to Service Fabric, removes the current application, and deploys the new one. Awesome. So now we have some kind of diagnostic events, and what you see in a minute here is some Service Fabric internal messaging, which helps you to understand what's actually happening if you want to debug the thing. And at some point, we will see our service who starts counting. There we go. So we started at 0, and we just counted up. Awesome. So that's cool, but it's not impressive at all. So now I'm here at the so-called Service Fabric Explorer, which is basically a web view of Service Fabric to see how my cluster is doing. And I want to see the message. Okay, so let's have a look. So we have in my cluster some applications, at this time 2, our stateful test type. And you see how you can talk to the things. It's just a DNS service basically running in Service Fabric. And if you ever ask the question, what is actually Service Fabric? Service Fabric is a microservice running on top of Service Fabric. So yeah, that's naming service, DNS service, cluster management are all services running on top of Service Fabric, which is quite cool, I think. Okay, so I see I have one service, I have one partition, and I have a primary and active secondary nodes. Why do I need this? Failover. So what actually happens is, right now I'm talking to node 2. And every request I send to node 2 will be replicated to node 1 and node 3. Yeah? So state persistency. The primary node right now is getting all the messages, and I know it's on node 2, and I'm a bad guy, and I say, okay, node 2, I want to kill you really, really bad. So, what's happening now is we are deactivating the process locally, where the service is running, and you see on the right, Service Fabric actually figured out, wow, there's something going wrong, we need to activate the replica. And we just still counting. We didn't even notice that there was a failure. And this is a distributed system. And why I'm showing you this with a service, not with an actor, is because actors work the same way. It's just magic. Yeah? And you can have reliable state within your actors or into your services, and just Service Fabric takes care of the rest. And if you go back to the management overview, we see that the new primary node is primary node 1, and Service Fabric created a new replica for me, which gets replicated messages and is up to date with the state. And I run into the breakpoint. Awesome. Okay. Now we know what Service Fabric does and how it works. So how do actually actor systems work? Or how do actors work in Service Fabric? Just open up the new actor test. And the idea is basically, for each and every actor is basically a class definition, and you can have state within this actor, and you have an interface for the actor. So if you think about microservice or application boundaries, your interface to the actor is actually your application boundary, or your contract you're actually talking to. What is an actor? It's nothing else than just a class divided from actor. And your own interface, iActor. And iActor is basically the contract you have for your application how your application can talk to the actor. In this case, we have just get count asynchron and set count. Okay, so actor system, actor on activate is basically what happens when an actor wakes up. So we talked about actor systems, and we talked about that actors handle their own state and they handle it in RAM. Okay, but what happens if I change my state? Or I need to change my state. So add a new value to my state, remove a value to my state, add it into a long, for example. And this is a problem you will have in actor systems, migrating your old state into your new state if you are doing upgrades with your actors. And on Activate Async is one of the solutions you can actually use in Service Fabric to tackle this problem. Because this actually says, okay, I get called if the actor gets activated. This means as soon as someone will talk to the actor, this will call. And I can handle, at this point, state migration. So I can just load node state, migrate it to a new entity, and save the state again. Okay, how does state work in an actor? Just like a service. And I can add there anything I like. So I can just take any entity class I have and put it in there. It just needs to be data contract serializable in the C# world. I don't know what the equivalent would be in Java world. But it's the only thing you need to take care of if you want to persist state with an actor. And the state you put in this actor is private for the instance of the actor. Yeah? So if I have, for example, I have a user actor, and I want to have a new user, I just say, okay, actor system, give me a new user with the ID 1, and you will get an instance of this actor. And everything like the name, the email address and stuff like that will be saved privately in this actor. And if someone else wants to get information from this actor, he needs to talk to the actor over the interface. That's the basic idea. And once again, what we're doing here, nothing special, just get state async and add or update async. So right now I don't have an implementation of that, but I will show you later. Okay, it's getting better and better and complicated. Awesome. So the next thing I will show you is a more complicated project. This project is basically developed to show the capabilities of Service Fabric. It's open source, you can find it on GitHub and can dig into it at any time. And we will just collapse this to make it more appealing. So, awesome. So what you can see, we actually have the stateless service here, we have the stateful service here, we have the actor model here, and we have something called guest executable. If you remember my presentation, we talked about we can run every code on Service Fabric, but what does this mean? And it's really easy, because I can just put an executable into my Service Fabric project. Okay, fair enough. And I just created a Service Fabric manifest for this executable. And what it's saying is basically, okay, just take my executable and host it for me. And at this point I can tell Service Fabric I need at least 10 replicas of my executable. Or I want this executable to be run on every server in my cluster. For example, if you have a stateless REST API, yeah, as a service, you want to run this on every server in your cluster. Why? Because you need load balancing otherwise. If you have load balancing to figure out, oh, this server isn't running a REST API, I need to talk to a different server, it's really, really bad. Yeah? So this is something Service Fabric actually does for you. And in this thing, we just open port 8080 and listen to it. And you can basically do this with every executable, even on Linux. Okay, so let's show you the sample and the application. So this is the getting started application. As you can see, I have different services or different types of services running in my application. This could be an actor, this could be anything else. I want to go to the web service, and I see I have a partition for my web service. At this point in time, just one. Why? I'm running locally. And if I want to listen to port 8080 10 times locally, what will happen? It will break. So I just have one partition in this case. So I get in there, and I get the listening address of the service. And if the demo god's liking me, it will work. It works! Awesome. So, and I can just see what my guest executable actually has as a response. This is just the executable running on Service Fabric and orchestrated by Service Fabric. I can do the same thing with stateful services. I can just have key value database basically. Hello world, also we are mixing German and English because we can. And we're just adding it. And we get in return. And if I get all, awesome. So that's the stateful service I showed you earlier. And how does the actor look like? I can just create new actors, as many as I want, from the same actor type, and have 31 actors running in the system right now. What do you think? Okay, so I'm an artist, so the next thing I will show you. Oh, awesome, new version. I don't care. Okay, so when do I actually want to use an actor and when do I want to use a stateful service? Because they are basically doing more or less the same thing. Both can handle state. When should I use what? Okay, so if you think about it, I have a stateful service and I want to have connectors coming to that. It's awesome. Why? Because I have state which gets partitioned by Service Fabric for you. Cool? So everything we learned about earlier about microservices and state handling, we already have with a stateful service. So how does actors work? Let's imagine we are building a football game, just hypothetically. No one has done it before. So I have an actor type for users. I don't think and we have an actor type for users. And we have a user actor. That's complicated to draw. Really, really complicated. That's cool, but I want to have more users. So I have just more instances of my user actor, which is really, really cool. So why is this interesting? Because every actor could run in its own partition. And if you think about state before, this is how we can scale state in an application. And if you compare a stateful service with a stateful actor, it's quite different. Because the whole actor is living on a partition. And the stateful service is just the state living in a partition. Yeah? Why is this interesting? Because the actor is single-threaded. I just can process one message at a time, not more. So if you think about it, okay, I understand there's partitioning, there are users, there are actors, so when should I use an actor? For example, I have one service, my user service is an actor, or anything else. Could be a client, could be anything else. So this user needs to generate stuff. In our example, just say he wants to generate football players for my team, because I'm a new user and I want to have a team when I want to play. So what I need to do is I need to generate 22 football players. So what I can actually do at this point, I can distribute the workload to kicker actors. So I can dispatch 20 or 22 requests to the actor system and just say, get me a player for the ID 1, 2, 3, 4, 5, or any GUID you have. And at this point, my actors are running again on different partitions. And what this means is that I don't have a bottleneck at this point. So every time I want to actually distribute workload over more than one VM, or more partitioning, or have state that needs to be managed, an actor is a really great choice. But what's bad about an actor is that if we have something like this, so I have a user and I have, let's say, 10 consumers wanting to talk to this user. So what's the problem with that? Is that internally we have a queue and everyone puts his message in the queue and they pull out one at a time, if they are talking to the same user. If we have more users, so more instances of the same actor, this would be okay. But if everyone wants to talk to the same actor for the same actor instance, we have a problem with performance. And the reason is that we have a messaging queue inside the actor which pulls out the messages and works with them. Okay. So, anyone has an idea how partitioning works on a low-level basic? Okay, so I show you. Let's imagine we have a cluster of VMs. Just 5, just by accident. Okay, so how does this work? For example, at this point I say I have 5 partitions. So every node has its own partition. Awesome. Now I have a service running on that node. My red service. Cool. And the state there will be replicated to other partitions, but we make it easy this time. Okay. Awesome. What happens if I put more VMs inside my cluster? Just imagine I start having more VMs and I still have 5 partitions. And my service is running there. We had one before. If I scale out a cluster and doesn't scale the partitioning, I won't get any performance increase at this point. Why? Because partitioning is the limiting factor if you're handling state. So if you start something like this and think about partitioning in a service-centric way, you need to choose a partitioning size when you first deploy your service. And what we usually tell our customers is, or customers I work with, choose a high number. So if you have 5 nodes, don't go with 5 partitionings, go with 20 or 30 or even more. Just to make sure that if you need to scale, your partitionings will scale with you. Okay? So, other question. You are all microservice developers and you all have some production system to manage. How big are these production systems? I want to know. More than 10 servers. More than 100 servers. More than 1,000 servers. Yeah, that's the funny part. So, I have something called internal Azure subscription, and I have really fun using it. So just to show you guys how it actually will look like, this is Azure, for everyone who doesn't saw it before. It doesn't bite, it's really, really cool. Okay, so what I have here is a server-serving cluster. And I have a server-serving resource, and I can dive into it, and I have 50 nodes. And I don't have just 50 nodes, I have different nodes. For example, think about you have a Docker container you want to orchestrate. Server-side can do that too, by the way. So we can orchestrate Docker as well. So you put a Docker container into Service Fabric and say, run. Service Fabric will do it. But what happens if you have a Docker container who uses NVIDIA GPUs? How can I actually manage this? And this is a simulation of that, basically. I can have different types of nodes inside the Service Fabric cluster and can define services to run on specific nodes. And Service Fabric does the rest for me. So if I have an actor, for example, who is compute intensive, I can have high CPU nodes running these kinds of vectors. Or if I have an actor which has huge state, I can have nodes with more RAM to actually accomplish that workload. And once again, this is a public cluster, so there's a way to secure it, but I didn't because it's easier. Just to show you how it works. Okay, once again, I have my different nodes here, I have my application here, and just to give you an idea, this is the stateful test application we had earlier, so I don't have an active debugging session for it right now, but as you can see, I have 50 or 80 partitions for that service. Why? Because I wanted to scale. And I can go into each partition and ask, where are you running? In this case, node 26. Okay, so how can I actually deploy to Service Fabric? If I have a remote cluster, we just saw it with Visual Studio tooling. It's the same thing with Visual Studio. Just go, say publish. You can directly link up your Azure account, for example, and you can do something like upgrade the application. And here I can define what will happen if an upgrade fails. So we talked about actors earlier. If I want to have an actor who does state migration, it is possible. You need to do it yourself, but something can go wrong if you upgrade the thing. You can just throw an event, Service Fabric will recognition the event, and roll back your state and your actors and your services automatically. So this is the only way we can actually get a highly available system and a system that scales well. Okay, so if I update something, as you can see, I have two different things I can update. The code and the configuration, independently. In this case, I unfortunately don't have any changes to my code, so I can't do that, but I... Let's go into code here. Awesome, how everyone should program. And just publish the thing, upgrade application. Okay. Now he detects changes I made, increases the version number, and updates this on my cluster. Okay. Yeah, who cares? Okay, why are I showing you this? Because if I go to my cluster and go to upgrades, this is my local cluster. This is the wrong one. This is the real one. And I see that the upgrade is already done. Why? Because it was a stateless service. If I update the other one, the backend service, and publish this. Actually here that I have updated the version, save this, hit publish.
So one question, you just registered that simple application as Untitled service plan?
Yes, so what we can dive into that a minute later. I just show the update and we'll talk about it. Okay. The demo gods are not with me today. I'm really, really sad about it. Okay. Normally, you will just ignore the errors and just do it. Normally. Let's give it some time. Okay. Then not today. So back to your question. What actually is an actor in Service Fabric, and why did I tell you earlier that you can run any actor system on top of Service Fabric? Not you can just host executables, but if you go into an actor, for example, backend service. So this is an actor. This is an actor, and I start to say the state is persisted, and I can even choose how the state will be persisted. Yeah. So if I need to write every change to the hard disk, it will be less performant than just having it in the RAM. So I can decide. And in this actor, I just have a class definition, some state, which gets handled, and something called reminder. I come to that in a minute. So, but what this actually is if you look at the project, I just register an app object to the first Service Fabric runtime. Yeah? And you could register a service to the runtime and host in that service your actor model of your choice. So you can basically put in akka.net or Orleans or even akka on Java if you like, but get hosted by Service Fabric, and you get all the features Service Fabric has and run your own actor model. So we have seen something like what is an actually reminder. And a reminder is something like, it's really, really interesting. So just imagine I have a player. And the player gets older. Every 10 minutes, for example. How would you do it in a traditional way? You have something like a web front end, yeah, and get requests. And as soon as you get a request to here, you have some kind of logic which calculates how old the player got actually between the last timestamp. So the time delta, you get the time delta, have function actually calculating the new age of the player, which is cool. You can do it that way, but for some functions that put it that way, the math behind it gets really, really complicated, especially if you try to simulate games. I tried it, it's really not that great. So what an actor actually can do is, you can register a reminder on an actor, which is basically some sort of timer which triggers the actor on a specific function every 10 seconds, or every day, or every 10 days. So instead of having a complicated algorithm calculating the new age, you can just increment it by 1, register a reminder for a year, and you are good. So just by using actors and the programming models behind it, you can get stuff like that and get really, really easy algorithm. Just by doing that. Okay? So I think I showed you everything I have today. I have a few questions. Yeah.
Does the reminder fit over as well? So the state of the reminder?
Yeah. So they actually, in Service Fabric, there are 2 kinds of reminders. One thing is reminder, the other thing is a timer. Yeah. And the one thing, timer, is something like, as long as the actor lives, the timer exists. So as soon as I don't have any requests against my actor and the actor gets persisted to disk, the timer will be gone. As soon as the actor gets activated by an external call again, the timer will be there again. A reminder works a bit different. A reminder is something like, okay, I have a player, every year he gets older. After 4 hours, my configuration says, okay, no one wants to talk to this player, just put it in the disk. But the reminder is still running. So after a year, the reminder will activate the actor, increase the state, and put it away on disk. So these are basically the two types you can actually have in Service Fabric. Yeah.
How can you query the state? Because when you have the actor, you can ask the actor for the state. But if you want to have all players that are older than 34, for example, how would you do that?
Yeah. So that's a good question. And that's the bad thing about an actor model. So as soon as we have something like relational data, actors get really, really complicated. Why? So if you think about our partitioning, for example, our actors are distributed along these partitions. Let's say we have 100 partitions. So what I need to do to actually find all the actors which have a player with a name or something like that, yeah? I need to query all the partitions, get all the actors, and find the right actors I want to talk to, which is really, really bad. So what you could do is you could have a service, stateful service, with a dictionary holding the IDs of the actors you want to talk to. But actually querying relational data or relational problems to an actor system doesn't work well.
Would it be possible to have I mean, for archive, for example, we could implement something like CQRS.
Yeah.
Is that possible with these actors here?
Yeah.
Okay, so they can publish the events they store. Or
Yeah, sure. But you need to build it yourself. So, I mean, if I'm an actor needs to write something out to an event log, basically. Blob storage or some other thing.
yeah, but yeah, for me it sounds like it is some magical logic that handles this state persistence.
Yeah.
So how can then I have to, if something changes the state, I also have to write it somewhere else.
Yeah.
And how do are there possibilities to synchronize this? But because then I have some kind of transaction.
Yeah. So you can have transaction actually in an actor model, so the state is transactionable. But what you are asking is, okay, I have my cluster, I have my 5 kickers, for example. And now I want to get all the kickers from one team. That would be one of the questions you would asking, right? You get this right? From the idea? Okay. So I can do two things. I could have a team actor who has a reference to my kickers. This would be one thing. So if I want to talk to the team knows about the kickers and I get the kicker. This would be one thing. But if you want to have some sort of SQL query language against it or have some analytics basically over your kickers or over your users, you can't do this easily with an actor system. You would implement it yourself in a different actor which have the references, or you have your actors. What I implemented for disaster recovery is that every time an actor changes his state, he will put his state into a blob storage. Costs like $10 a month for 10 million users, so you can just ignore the price. But every time the kicker got a change, the change was persisted to the blob storage. Why? In this time it was just a blob storage because I can just mount this thing in a Hadoop cluster and do big data on it, if I like, because it's just JSON formatted strings. But you could do it in a SQL database as well. But you wouldn't use the SQL database to do your production query against.
But if I have so many actors, wouldn't I have again the bottleneck problem?
Exactly. Yes. So as soon as you introduce the new persistency layer, you still have the persistence problem you would have normally.
But you could here again use something like message queue.
Yeah.
Yeah. And you have event consistency.
Yeah. So the thing is, do I really want to have relational data? Or what do I want to do with my data? That's the question you should be asking yourself if you are thinking about the actor model. So you can use the actor model for simple stuff like this, or really, really complicated stuff. But maybe it's a good idea to write your state somewhere else too, to just have the analytics capabilities. Does this answer your question?
Yes, as long as you can write it as a transaction. You said that's possible, right?
Yeah.
Let's assume I have a chain of multiple actors. Is it possible to find quality of service for a whole chain?
So you mean if one part of the chain fails?
Yeah, actually that, for example, the client gets the message that the last actor receives the data at least once or...
Mm-hmm. So every call is asynchronously at this point. But you will have the same problem you will have with normal microservices. So what happens if this fails? Does the client get a response? Per default, no. But you can implement it this way. You could implement saying, okay, this actor actually responds right after that and follows the chain. And at some point you can query or poll the actor again and get the state. So there's no easy way to solve it. You need to have an architectural answer to that problem. Because actors don't solve that problem for you. But what you can do is you can trust into your orchestrator. You can just say, okay, these things will never happen. They will never fail. Because you trust your orchestrator that the orchestrator is highly available.
But does it guarantee that I have at least once, most once, exactly once?
Yeah. So what you can basically say is, in Service Fabric, for example, you can say, from this service, I want at least 3 at all times.
Well, I mean the message flow. If you have a message, and you can guarantee that exactly once the message goes to the next flow.
Okay. No, you can't do this. So I actually have this problem you just told us before, because what we had is we have reentrancy into actors. So an actor is single-threaded, but an actor instance can call itself. Yeah, and here are we again with concurrency. Because you are in the same actor instance twice. So you need to take care of something like this.
So what is the problem? If the actors are re-entrant, is there a problem? Is there a problem?
Okay.
They send a message to themselves.
The thing is, not that they are sending the message for themselves. The thing is, think about multi-threading. Yeah? So you have one actor, and the actor is per definition single-threaded. It's awesome, because every time I write some data, I know I'm the only one writing the data. And as soon as I read the data, I know that I'm the last one who wrote the data. I know what the state will be. Awesome. So what happens if this changes? So I have reentrancy into my actor. Yeah? So I have a second instance of my actor. Let's use a different color here. So I have a second instance of my actor who has access to the same state. So what could happen is, before this actor here reads the state, the other actor compromises the state.
By definition, this is not possible in the actor model.
Exactly, as long as you don't have reentrancy into your actor. Because you can build stuff like that. It's not easy to build stuff like that, but you can. Yeah? And here's the problem. It depends on the implementation. So in Service Fabric, you have to define a method that the actor is actually allowed to re-enter this method. So you can make sure that only methods that are stateless can be re-entered. For example.
But when actor sends message to itself, is it the same queue or it's just message call?
It's the same queue.
Then these things, right?
It depends. It depends. The thing is, yes, you are right, because one message gets at a time. At this point, it's an implementation question. So in Service Fabric, actually, you can re-enter and open the same actor over and over again. And if you have a long-running actor, so logic that's running long there, he will pull out the re-entrancy messages. So re-entrancy is not that easy as I showed you before, because it basically skips the queue, kind of.
mentioned something earlier about when there's multiple instances, it makes a copy of the request.
You mean the replicas?
I thought that you said that it made, if you had multiple replicas, that it made a copy of the request.
Yeah.
I just wasn't clear on what that meant.
Okay, so for example, we have a user A, which is an actor. And I get messages for user A. Awesome. The problem we will have if actor A fails, because the state will be gone. So what actually happens in Service Fabric is that we have replicas of state. In this case, replicas of the actor. So I have two different instances of the actor, which gets the same message as the primary actor. So the state gets replicated to multiple instances. And the blue ones would be the secondary, and the red one the primary. So what I showed you earlier with the failover, where I deleted the node 2, so the application is gone, but anyway. Awesome, this application doesn't have replicas. Here. So what you can see here is that for this service, the stateful backend service, which is the backend actor, it has two partitions. In one partition actually lays one primary node, the red one, and two secondary nodes, the blue ones. And once I kill, for example, node 0, now I won't kill my Service Fabric cluster, but I will generate a fatal error because I have less nodes in my cluster than Service Fabric is supposed to have. You will see that the primary node is gone, and the secondary takes over the messages for the primary node.
And what happened to the state?
You mean the state at the VM?
Yes. So node does not equal actor.
No.
Okay.
No.
Okay, I see.
When I say node, I mean a VM, basically.
I see. Okay.
So I just wiped the VM, but the state is still there because the state got replicated to the different actors for the secondaries. And as you can see, we have a new primary, which is node 4, which was previously a secondary actor, and we created a new active secondary actor to have at least two replicas of my state inside my system so that it really is persistent.
Okay, I got you. So because this is such a different point of view than an HTTP microservice, where those requests are bound to a service, your requests more or less are bound to the actual object, the actor itself. You're replicating the request so that if you have to fail over, that request is still there, so that action can act on it.
Yeah. So depending on the implementation you choose, it's different how this is handled.
Yeah.
So internally, Service Fabric is not just saying, okay, I have one message, make 3 out of it, because this wouldn't be performant at all. Yeah.
My question is from the scenario that you mentioned with the actor. I mean, we are thinking from three-tiers system, like three-tiers communication. My database now is distributed over the actors. This is right in the case of the Service Fabric. Like, my assumption is right or valid or?
If you choose to implement a database with an actor system, yes. But the question is, do we want to do that?
No, I mean, I should find a way kind of to distribute the data through actor. This is like how Service Fabric works.
Mm-hmm.
I mean, or the actor model.
Mm-hmm. Yeah.
So in case of like systems where really like the database is like a centric solution, it would be also like where many queries are, it would be, the actor would be like really problematic.
In this case, an actor could be a problem, a solution to your problem. Why? Just imagine you have a database, and you want to decouple it from your microservice architecture or something like that. What you usually do is you introduce a cache. Yeah, but what we talked about earlier. So you have a caching system where you run your request against. It's awesome. But you could replace your stateless part, so your stateless implementation and your caching implementation with an actor. But have the actor write their state to a database. So you still have the database to do your SQL query against, but the actor basically will be your cache. And what this allows you is to put your state and your code together, which could be good for your problem. Might not, but could be a solution to your problem. Exactly. Exactly. But it doesn't matter that much, because no production queries are against the database, because the production queries are against the actors. So, yes. You still need to decouple it, yes.
You could build like a hierarchy of actors, hierarchy of caches, which decouple it depending on the needs.
Yeah.
So you build your own level-based cache system.
Yeah, but that's the problem. Yes, actor models aren't relational, and actor models aren't databases. That's the problem with that. So as soon as you want to use a database again, you will have the database problem, as we had before. But the idea about an actor is that you don't need the database anymore. That's the basic idea. That's not right, I think. So, for example, what I showed you earlier with the kicker example. There's no database involved at all. The only thing that was involved was a disaster recovery blob storage, where we wrote our state, persisted our state outside the actor system, because we wanted to kill the whole cluster. Okay, we wanted to delete the state in the whole cluster. Why we wanted to do is a different story. But in this case, we haven't had any database involved. And we didn't want to have any database, because we didn't want to have any queries against our kickers in the system. We don't want to know how many kickers we have that are 20 years old, for example. It's not a question we had. And for the example with the user, concurrent user and stuff like that, we had utility actors basically who took care of these kinds of questions. So we haven't wrote any SQL queries against a SQL database to see how many concurrent users we have. We just had a reliable service taking care of that.
I just can't imagine any realistic scenario where you would do something like this almost without a system.
Yeah, the data is still persistent in the actor system. That's the point. It's still persistent. The question is, what do we want to do with the data inside the system? So how do we want to work with the data? Do we want to have SQL queries against it? Or relational questions? Then an actor system is problematic. But if you just say, okay, I just want persistent state, an actor will do fine.
I mean, isn't the problem, I mean, if you need absolute consistency of your data at some centralized place, then the actor model is a problem.
No.
Is it? Because, I mean, actors,
the thing about that is, just imagine what you have, and you have one server running the database. It's in a single place. But if you want to have a failover, the data will be in two places. Or what do you mean?
I mean, so if there is an assumption that any queries I make from any point in my cluster, in my actor system, will yield the same result if I do that concurrently. So that cannot obviously be guaranteed, right? Because if those writes to the database are done from different actors which do not explicitly communicate that or synchronize in some So then obviously there needs to be some asynchronous, that database will be filled asynchronously. At some time, at some point, it will have some state.
Yeah.
So, and whenever I do that query, whenever I send a query to the database, give me the data, what you see right now, you obviously will not get the
Yes.
So, and maybe isn't that a criterion to decide when to use? I mean, if you have that requirement that the data must be consistent every time and any time, isn't that a criterion?
The thing about that is the data is still persistent in the actor system.
But it is potentially, eventually, it will have a steady state at some time, at some point in time.
Okay, what we are thinking right now is that if we write the state in a database in parallel, so that's a good question, but that's not what I mean when I say the state is persistent. If we talk to an actor into the system of Service Fabric, the state will be persistent all the time and it will be consistent.
The state of single actor?
Yeah.
But not the state which is kind of influenced by more than one actor.
This will be consistent too, because the actor who handles the state is single-threaded and just can write once.
Okay.
I believe we might have a follow-up discussion around this in a smaller group who have more questions with less deeper technical things which we can't solve in big group now, or otherwise I would say that be time for beer. One last question. How do I debug that?
This is actually a good question. So, yeah, that's the answer. Yeah.
Sorry.
So
you just attach the process with Visual Studio, and that's it.
just let me show you.
You can do the same thing with an Azure. So if you host a web API or something like that, you just can attach the process to your Visual Studio. Yeah, for sure, you will have the access. When you run it locally, you can do the same thing.
Yeah.
Just attach the process, and that's it.
So you can debug a single actor, but I believe in addition to a distributed system with many actors, debugging does not mean I see how one actor behaves. So that is all the things around monitoring and logging will still be
interpreting logs somehow, right?
So that's another hour.
we had other talks on that one. So this is an urgent one, I believe, because
I'm not sure it was urgent. I think this side of the room didn't get.
you didn't get a question. Therefore, you need another one.
But it might be an easy one in terms of maybe you know, maybe you don't. You referenced 3.4.3 for Halo and
Yeah.
IO. They use the actor model or the service fabric.
They are actually using the Orleans actor model,
Yeah.
and the reason for that is that Service Fabric wasn't public then.
Yeah.
So,
But do you know what kind of problem they tackled with it?
the whole high frequent web API, basically, and real-time data about their game sessions.
Yeah.
So the idea is how many players are in a specific game, for example. Because if you have an actor who actually knows that, you can just create the actor instance and you're good. For these kinds of things, they use this.
But you picture that the actor is the game, so it can keep, the actor is a game.
Okay, so in this implementation, it was just an actor to have state, which wasn't the real-time simulation of the game.
Yeah.
But you can do real-time simulation inside of actors on top of Service Fabric. One of my customers actually does that, but at that point it gets really complicated.
So now we make the wrap. You will stay a little bit longer, but he's tired and has to catch an early flight tomorrow. First of all, I want to wrap it and give him a hand of applause. Interesting topic, a lot of very good questions. I believe just grab a beer. You also might need you still have one. So just grab a beer and ask the questions directly. Yeah. We might have a help group around transactional boundaries and eventual consistency this corner after I have grabbed the beer. Thank you very much. It was a pleasure. Thank you.